Welcome back to the deep dive. We've got some really interesting source material today that you shared. It's excerpts from the International Software Testing Qualifications Board, focusing on managing the test activities.
That's right. It's essentially the playbook for how you effectively manage testing and software development. Covers all those core concepts.
And our goal today, our mission, if you like, is to pull out the absolutely essential knowledge from this document. We want to give you a quick way to grasp the purpose, the processes, the techniques for, well, planning, monitoring, controlling, and finishing up test activities.
Yeah, and also how to handle risks, which are always there, right? Plus, managing configuration and dealing with defects. All the key parts.
We'll definitely explore test planning essentials, how to navigate risk, keeping things on track with monitoring and control, what to do with defects, and configuration management's role too.
So a pretty comprehensive look at the management side of testing.
Okay, let's unpack this, starting right at the beginning. Test planning. Why bother? The source seems pretty clear it's more than just paperwork.
Oh, absolutely. It's fundamental. The document highlights several key reasons. A test plan, you see. It documents how you'll test the means, the schedule. It's there to ensure your activities actually hit the targets, the criteria you set.
And it's a communication tool as well.
Hugely important for the team, for stakeholders. And it shows you're following the agreed test strategy, or crucially, if you're deviating and why. The planning process itself, well, it makes you think.
Right, forces you to anticipate challenges.
Exactly. It guides your thinking about potential roadblocks, risks, schedules, resources, costs. The source lists typical contents like defining the context, scope, objectives, what you're testing against.
Assumptions, constraints, who the stakeholders are, their roles.
How you'll communicate. That initial risk register you mentioned, it's all in there. Plus the actual test approach itself.
Like the levels, types, techniques, deliverables, those entry and exit criteria we'll get into, metrics, test data environments.
And of course, budget and schedule. It's quite detailed. And it points to the ISO 291193 standard if you need, like formal templates.
Gotcha. Now, where do testers fit into this planning, especially with iterative approaches like Agile being so common now?
Testers are absolutely key partners. In release planning, that bigger picture view, they help refine the backlog. They actively participate in risk analysis for the whole release, estimate the test effort.
Help figure out the overall test approach.
And plan how testing fits across multiple iterations. They're involved early.
So shaping the release. And what about iteration planning, that more immediate sprint level view?
Right, that's much more focused. It's about the specific iteration backlog. Testers do detailed risk analysis for those stories. Assess their testability, like, can we actually test this properly?
Then break down the work.
Yeah, break down stories into specific testing tasks, estimate effort for those tasks, and really nail down the functional and non-functional testing needed for just that iteration's work.
Okay, this next bit often trips teams up, I find. Entry and exit criteria. Sounds simple. When do you start? When do you stop? But it's tricky.
It's so fundamental, though. Entry criteria are those preconditions. What must be true before you can even begin a specific test activity. Trying to start without them is, well, usually a recipe for wasted effort and delays.
Like what sort of things?
The source gives examples like, are the necessary resources actually allocated? Is the test where your cases, scripts, data ready to go? Has the software passed some initial quality gate, like smoke tests?
Okay, so are we genuinely ready to start? Then what about exit criteria? What do they tell us?
Exit criteria define when an activity is considered done. These are your targets. They might be quantitative measures, hitting a certain code coverage percentage, maybe a specific defect density.
Or a limit on outstanding high-priority defects.
Exactly. Or they could be more binary yes-no things, like, have all planned tests been executed? Is static testing complete? Are all defects reported?
And these would differ depending on the test level, right? Component testing versus system testing.
Absolutely. You tailor them. Component test exit criteria will look very different from, say, end-to-end system test criteria.
Yeah.
The source also mentions a practical point.
Which is?
Sometimes you might hit external constraints, like running out of time or budget, before meeting all the ideal criteria.
Ah, the real world intrudes.
It does.
Yeah.
But critically, the document says if that happens, stakeholders must review and formally accept the increased risk that comes with stopping early. It's a conscious decision.
That's a really key distinction. It's not done, it's stopping. And here's the risk. The source also links these to Agile concepts.
Yeah, it maps nicely.
Yeah.
Exit criteria for potentially shippable software often aligns with the definition of done. And entry criteria for starting a story can be part of a definition of ready. Makes sense, you know?
It does. Okay, let's switch to estimation. How do we figure out how much testing effort we actually need? Feels a bit like gazing into a crystal ball sometimes.
Yeah, it can feel like that. Estimation is inherently tricky, based on assumptions, always has some error. The source wisely points out that estimating smaller tasks is usually more accurate than trying to estimate massive chunks of work.
Makes sense. So what techniques does it suggest? There were 4, I think.
That's right. First up is ratios. This is metrics-based. You use historical data from similar projects you've done before.
It's your own team's experience.
Exactly. Like, if historically your dev to test effort ratio is, say, 3.2, and dev effort is estimated at 600 person days, you'd estimate testing at 400. Quick, but depends heavily on having good, relevant historical data.
Okay, using the past, what's next?
Extrapolation. Also metrics-based, but uses data from the current project. You measure effort early on, maybe for the first few iterations in Agile.
And then use that trend to predict the rest.
Pretty much. You use that early data, maybe with a simple mathematical model, to project the remaining effort. Works well in iterative cycles.
Right, using the present to predict the future. The other 2 are expert-based.
They are. Wideband Delphi is one. It's iterative. You get a group of experts. They estimate individually, anonymously. Then you discuss the results, especially the outliers.
Figure out why there are big differences.
Right. Then they re-estimate, again, individually, until you reach a consensus or the estimates converge within an agreed range. Planning poker in Agile is basically a variation of this.
Okay. Planning poker comes from Delphi. Got it. And the last one?
3-point estimation. Here, experts provide 3 figures for a task. Optimistic, best case A, most likely F, and pessimistic, worst case B.
And you combine those somehow?
Yep, using a weighted average formula. The estimate E equals A plus 4 meters plus B, 6. It gives more weight to the most likely estimate.
Okay, that gives you a single number. What's the advantage?
Well, the real power, as the source highlights, is you can also calculate the uncertainty or error margin using the standard deviation, SDA equals BA6.
So you get a range.
Exactly. The example given, A 6 hours, M9, B 18. The estimate E is 10 hours. The SD is 18 to 6 equals 2 hours. So your estimate is really 10 plus or minus 2 hours, or 8 to 12 hours. Much more useful than just saying 10 hours.
That really does make the uncertainty explicit. Okay, so we have estimates, we have test cases written. How do we decide what order to run them in? Test case prioritization.
Right. You rarely just run them randomly. The source outlines key strategies. First, risk-based prioritization. You run the tests covering the highest risks first.
Makes perfect sense. Find the big problems early if they exist.
Precisely. It ties directly back to that risk analysis we'll talk more about. Then there's coverage-based prioritization.
Focusing on covering requirements or code.
Exactly. Prioritize tests that give you the most coverage early on. A variation is prioritizing based on additional coverage. What test gives me the biggest chunk of new coverage I haven't hit yet?
Okay, and the third main one?
Requirements-based prioritization. This is straightforward if your requirements are prioritized by stakeholders. You run tests for high-priority requirements before tests for low-priority ones.
Simple enough, but reality often gets in the way, right? Practical thing.
Always. The source mentions dependencies. Test B needs test A to pass first, so A runs first, period. And resource availability, maybe the performance test environment is only free next week, or the security expert is only available then. That dictates the schedule too.
Right, practical constraints. Now, shifting gears slightly, the source introduces a visual model. The test pyramid? What's that about?
The test pyramid, yeah, it's a really useful conceptual model. It helps teams think about different types or granularities of tests and, importantly, where to focus automation efforts.
So it's layered. How do the layers work?
Think of it as layers representing groups of tests. The key idea is the tests at the bottom layer are small, fast, isolated like unit tests. You need lots of these, and they should be heavily automated because they give quick feedback.
A wide base of fast tests.
Exactly. As you go up the pyramid, tests get broader in scope integration tests, UI tests, end-to-end tests. They're less isolated, slower to run, check more complex interactions. You need progressively fewer of these higher-level tests.
So fewer tests at the top, but they cover more ground individually.
That's the idea. Lots of fine-grained checks at the bottom, fewer coarse-grained checks in the top. The source mentions different names for layers. Mike Kuhn's original unit, service, UI, or others like unit integration end-to-end, but the principle is the same.
It provides a good mental model for balancing your test suite. Another model mentioned is the testing quadrants.
Right, Brian Merrick's model. This one's specifically helpful in an Agile context. Its purpose is to help everyone, developers, testers, business folks, visualize and differentiate all the different kinds of testing activities that happen. It uses two dimensions.
What are the dimensions?
First is business-facing versus technology-facing. Is the test primarily understood from a business perspective or a technical one? The second is supporting the team versus critiquing the product. Does the test help guide development, or does it evaluate the finished product?
And those cross to make 4 quadrants.
Correct. Q1 is technology-facing and supports the team. Think component tests, unit tests, component integration tests, usually automated, run frequently in CI, giving fast feedback to devs.
Okay, internal quality focus, Q2.
Q2 is business-facing and supports the team. These are your functional tests, examples, user story tests, checking if the software does what the business asked for. Can be manual or automated. API tests might fit here too.
So checking requirements from a business view, Q3.
Q3 is business-facing and critiques the product. This is where things like exploratory testing, usability testing, user acceptance testing, UAT fit, very user-focused, often manual, evaluating the overall experience and suitability.
Okay, real-world usage focus. And finally, Q4.
Q4 is technology-facing and critiques the product. This covers things like performance testing, load testing, security testing, reliability testing, the non-functionalities, except usability, which is in Q3. Also includes things like smoke tests, often automated.
That's a really helpful way to categorize all the different testing that goes on, especially in Agile. Okay, planning and models covered. Let's pivot to risk management. The source connects this to ISO 31000. Seems crucial.
Absolutely critical. Every project faces uncertainty, internal and external factors that could derail it or affect quality. Risk management is about systematically dealing with that uncertainty. It increases your chances of meeting objectives, improves product quality, and builds stakeholder confidence.
So what are the main activities involved, according to the source?
It boils down to two main things: risk analysis, which is identifying and assessing the risks, and risk control, which is about mitigation and monitoring. And this directly leads to risk-based testing, using that risk analysis to drive your whole test strategy.
How exactly is a risk defined here? What makes it significant?
A risk is a potential problem, an adverse event or situation. It's defined by two things: its likelihood, the chance it might happen, greater than 0, less than 1, and its impact, how bad it would be if it did happen. Together, these determine the risk level. Higher level means more important.
Got it. The source also makes a distinction between two main types of risk in testing.
Right, very important distinction. Project risks versus product risks. Project risks are about managing the project itself. Things like delays, budget cuts, skill shortages, team conflict, scope creep, supplier problems.
Things that stop you delivering on time or budget.
Exactly. The impact is on the project's schedule, cost, scope, or ability to meet its objectives. Product risks, on the other hand, relate directly to the quality of the software being built.
Like bugs.
Yes, but broader. Missing features, incorrect calculations, crashes, poor performance, security holes, bad user experience, anything related to the product's quality characteristics, like those in the ISO 20010 quality model.
And the impact here is on the user or the business.
Definitely. User dissatisfaction, lost revenue, damaged reputation, high support costs, maybe even legal issues, or physical harm in safety-critical systems. Product risks are about the value and safety of what you deliver.
Okay, that clarifies the two types. Let's dive into product risk analysis. The goal is focusing test effort. Right?
Precisely.
Yeah.
To minimize the residual risk left in the product when you release, ideally this starts early. It involves identification, brainstorming, workshops, interviews, looking at past issues to list potential product risks.
And then assessing them.
Yes, assessment. You categorize them, figure out the likelihood and impact for each, calculate the risk level, prioritize them, and think about how you might handle them. This can be quantitative, like multiplying scores, or qualitative, using a high, medium, low matrix.
So you end up with a prioritized list of potential product problems. How does that list actually influence the testing itself?
It influences almost everything about the test strategy. It helps determine the scope, what needs more testing. It drives decisions on test levels and types. And maybe we need more performance testing because that's a high-risk area. It influences technique selection and coverage goals. It feeds into effort estimation and prioritization test, the riskiest stuff first. And it might highlight needs beyond testing, like needing architectural changes.
So it really shapes the whole test approach. What about product risk control then, taking action based on the analysis?
Right. This is about the measures you take. Mitigation means actions to reduce the likelihood or impact, lowering the risk level. Monitoring means checking if your mitigation is working and watching for new risks.
What kinds of actions or responses are typical?
The source mentions options like risk mitigation by testing specifically designing tests to find defects related to the risk acceptance, deciding the risk is low enough to live with, risk transfer, maybe insurance or outsourcing, or having a contingency plan, what you'll do if the risk materializes.
And specifically for mitigating risks by testing.
The document lists several. Using testers with the right skills, applying appropriate independence, doing reviews and static analysis, choosing the right test techniques and coverage levels, using specific test types like security testing for security risks, and performing thorough dynamic testing, including regression.
Okay, risk management provides the why and where for testing. Now let's talk about keeping things on track once testing is underway. Monitoring, control, and completion.
Right. Test monitoring is all about gathering information continuously. How is progress looking compared to the plan? Are we meeting those exit criteria we defined earlier? Hitting coverage targets for risks, requirements, etc.
So monitoring is the eyes and ears. Test control is the brain and hands.
Good analogy. Test control uses that monitoring information to make decisions and take corrective actions. If monitoring shows a risk area is causing more problems than expected, control might mean reprioritizing tests to focus there.
Or adjusting the schedule if the environment is delayed.
Exactly. Or reevaluating exit criteria if there's lots of rework, maybe requesting more resources. It's about steering the testing effort effectively.
And test completion sounds like the finish line.
It is for a specific activity anyway. It's about collecting all the data, consolidating the testware you created, and capturing the experience when a milestone is reached, like a test level finishes, a iteration ends, the project completes, or a release goes out. It's about wrapping things up properly.
And a big part of monitoring and control is using metrics. Why is collecting all this data so important?
Metrics are your dashboard indicators. They show progress against plan and budget, they give insights into the quality of the thing you're testing, and they help measure how effective your testing actually is against its goals. They inform those control decisions and feed into the final reports.
The source listed quite a few common ones.
Yeah, things like project progress, task completion, effort spent, test progress, tests planned, run, passed, failed. Product quality metrics may be response time, availability, mean time between failures. Defect metrics are huge numbers found, fixed, density, severity breakdown. Risk metrics tracking residual risk. Coverage metrics requirements covered, code covered, and cost metrics too.
That's a lot to potentially track. How do we actually communicate this information? Test reports seem key.
Absolutely. Reports summarize and communicate status. Progress reports are for ongoing control. Usually regular, daily, weekly, showing progress, deviations, blockers, key metrics, new risks, and what's coming next, vital for course correction.
And completion reports are for the end of an activity.
Right. These summarize the whole thing, a test level, an iteration, a project, prepared when exit criteria are met, hopefully. They pull together data from progress reports and elsewhere. They evaluate quality against the plan, document deviations, list remaining risks and defects, and importantly, capture lessons learned.
And who gets these reports matters, right?
Critically, different stakeholders need different info. The team needs details, management needs summaries. This affects the formality, frequency, and content. Internal team updates might be informal on a task board. A final report follows a template, like those in the ISO standard. The source mentions it calls progress reports status reports, by the way.
Besides formal reports, how else is status shared these days?
Lots of ways, depending on the team and context. Verbal updates and stand-ups, visual dashboards from CI/CD tools showing green-red builds and test results, task boards, burn-down charts, email, chat tools, online documentation, often a mix. Formal reports might be more needed for distributed teams, but tailoring the message to the audience is always the main thing.
Tailoring is key. Okay, next area, configuration management. How does this help testing?
Configuration management, or CM, is crucial background support. It's the discipline for identifying, controlling, and tracking all the different pieces of the work products. For testing, this means the software versions being tested and all your test artifacts. Plans, cases, scripts, data, environments, results, reports.
So it keeps track of everything involved.
Exactly. And for complex things like test environments, it records all the components and their specific versions.
Okay.
Approved sets of items form a baseline. Changes to that baseline need to go through a formal process.
And this helps with traceability and being able to reproduce things.
That's a huge benefit. CM tracks changes, creating new baselines. This lets you trace, say, which version of a test case was run against which version of the software in which environment to produce a specific result. And if you need to reproduce a bug or verify a fix, CM lets you reconstruct that exact baseline configuration. It ensures everything is unambiguous.
provides that necessary control and history, and it links to modern automation.
Yes. CM practices and tools are often baked right into automated DevOps pipelines. CI/CD managing the versions of code, infrastructure, tests, and deployment packages.
Makes sense. Okay, last major topic, defect management. Obviously, finding defects is a big part of testing.
It's a primary objective, as the source states. And defect management is the process for handling what you find. When someone reports an anomaly, something that looks wrong, this process figures out. Is it a real defect, a false alarm, maybe a request for a new feature?
And this process isn't just for bugs found during execution.
No, anomalies can be found anytime. Review, static analysis, anywhere in the life cycle. The process needs a clear workflow. Log the issue, analyze and classify it, severity priority, decide what to do, fix, defer, reject, track the fix, confirm it, and close the report. Everyone involved needs to follow it.
Why is creating a formal defect report so important? What are the objectives?
The source gives three main reasons. One, provide enough information for someone, usually a developer, to understand, reproduce, and fix the problem. Two, the collection of reports helps track the overall quality of the product. Three, analyzing defect trends gives insights for process improvement. How can we prevent similar defects in the future?
What kind of information typically goes into a defect report? Let's say for a bug found during dynamic testing.
The source lists the essentials: a unique ID, a clear title, date, author, their role, what software version and environment, what test case or activity found it. The exact steps to reproduce it are crucial. Logs, screenshots, recordings help immensely.
Expected versus actual results too, right?
Absolutely. Expected versus actual. Then severity, how bad is the impact? Priority, how urgent is the fix? The current status, open, fixed, closed, etc. And references, like the test case ID.
That is quite a bit of info per defect.
It is, but it's necessary for efficient handling. Tools often automate some parts, like the ID and date. And again, ISO standard calls these incident reports and offers templates if you need that formal structure.
Wow. Okay, we have definitely dug deep into managing test activities today, pulling out those core ideas from the ISTQB material.
We really have. We've covered planning, risk, monitoring and control, completion, configuration management, and defect management. All those essential pieces.
And it's so clear these aren't just admin tasks. They're fundamental to ensuring testing is thorough, efficient, and actually contributes to product quality.
Totally agree. So hopefully, you now have a really solid framework for thinking about how testing gets managed, understanding the key concepts, and how they link together based on this source.
Absolutely. So to wrap up, here's something to think about building on all this. Consider how really getting good at these management concepts, planning well, managing risk smartly, using metrics effectively, controlling the process, keeping track of everything, handling defects systematically, how that lets teams move beyond just finding bugs.
Right. It's about more than finding defects.
It's about enabling teams to proactively prevent defects, to use resources wisely, and ultimately to build real confidence in the software. Doesn't that shift testing from just a phase to something truly foundational for quality?
That's a powerful way to look at it. It really elevates the practice.
Something to mull over. That's all for this deep dive. Thanks for joining us, and we'll catch you next time.